Hello, my name is Mariusz. I am responsible for technical support in Poland. Let me present three-phase hybrid inverter. This training would consist of 4 points. So, we can start. First point, mounting. Point 2, technical data and compatible energy banks, hybrid inverter connection and operating modes. First point, mounting. In the box, you will find things such as inverter, bracket, expansion screws and pan head screws, PV connectors, Wi-Fi stick, user manual, current transformers. And now a few words about correct installation inverter of the wall. Installation is quite simple. First step, we have to screw the wall bracket on the wall. Next step, place the inverter on the wall mounted bracket by holding the handle on the side. That's all. Please remember about avoiding direct sunlight, rain exposure, snow lying up during installation and operation. Minimum spacing left, right, top and bottom is 30 cm. Point 2. Technical data and compatible energy banks. Here you can see the dimensions of hybrid inverter. Width and height is about 53 cm. As you can see, the inverter is not too big and looks excellent. Now you can see technical data. These inverters you can oversize by 50% on the DC side. Max input current per MPPT is 30 amperes. Max short circuit current per MPPT is 25 amperes. Max input voltage is 1000 volts. MPP voltage range is 180 volts to 850 volts. Minimum input voltage is 125 volts. Minimum start voltage is 180 volts. We have two MPP trackers, one string on one MPPT. Max EPS output power is the same as hybrid inverter power. For 8 is 8, for 10 is 10, for 12 is 12 kilowatts. Compatible energy banks at the moment are Pylon-Tech, Dynes Tower Series, own Solplanet battery 2023. In the future, the base may increase. Maybe you will need to update the firmware inverter. Pylon-Tech looks like you see in the picture. The H1 version module is lower, because this module has 48 volts. The H2 version is higher. One module has 96 volts. Difference between H1 and H2. H1 has 48 volts. So we will have 3 to 7 modules. Max capacity energy banks will be 24.8 kilowatt hours. H2 has 96 volts. So we will have 2 to 4 modules. Max capacity energy bank would be 14.2 kilowatt hours. Dynes is wide. It looks like that. In the table you can see differences between T10, T14, T17. Usable energy 10.6 kilowatt hours, 14.2 kilowatt hours, 17.7 kilowatt hours. Point 3. Connection hybrid inverter. We have following terminals of hybrid inverter: PV string input ports, communication interface COM1, RS COM485, communication interface COM2, Wi-Fi stick interface, BAT port, signal line interface, update USB port, CT connect to CT, current transformer, BMS communication to battery CAN communication, NTC detection, grid, gen, but this port is not active, backup 1, backup 2. Remember to put on current transformers and the right colors. The correct sequences of the current transformers is important. The load sources should be connected here. The sequence of phases is important. In case of wrong sequence, the inverter should display an error and we will not work with the grid. If the phase sequence was incorrect and we changed the phase sequence on the inverter socket, remember to change the current transformers accordingly. If we change the phase sequence on another place after current transformers, we don't have to replace the current transformers. In this picture, you see how to connect the batteries correctly. Remember to connect the BMS inverter socket with the CAN battery socket. It is important. In some cases, the order in which energy sources are connected is important. The correct order is energy bank. After starting it up, wait about a minute for the inverter to start up, AC and backup breaker and DC switch. After this, it will be okay. The diagram shows a hybrid PV installation. We have energy bank, PV module, emergency load, hybrid inverter, household load, meters, in our case current transformers. Backup outputs. Inverter has 2 backup outputs in case lack of electrical grid. This is what a properly connected inverter looks like. PV modules, hybrid inverters, energy bank, load on EPS, load on grid, and very important, current transformers. To the backup output we can connect the most important devices in the building. For example, lighting, alarm, fridge and garage gate. If we need to connect 2 inverters, we must make 2 under the grid as in the picture. Devices, they must be connected independent. The same a battery and backup. This slide appears the full possibilities of the inverter. Operation in the on-grid mode with battery. Operation in on-grid mode without an energy bank. This solution is possible. Then hybrid inverter works like a standard inverter. Operation in off-grid mode. It is possible. We do not recommend such a connection due to the fact little sun in winter. It should be remembered that our consumption is smaller than production because otherwise we will unload the energy bank to zero. Off-grid operation without battery. Impossible. Why do we think this action is not economical? Because when we can have 8 kilowatts from the sun and we have consumption at the moment only 2 kilowatts, then we lose 6 kilowatts and we cannot to accumulate this at the energy bank. If there is poor sunlight and at the moment we have only 1 kilowatts, but we want to consumption 2 kilowatts, this is impossible then, and we cannot to load from energy bank. Therefore, we recommend using the energy bank. If there is no voltage on the grid, the inverter works with the PV and the battery or the battery itself. So, no voltage on grid and devices on grid no works, but we have voltage on backup with the battery and PV. Then we have to route the cable from the main switchboard to the AC switchboard of the inverter and return to the main switchboard for the devices on the grid. Common questions. Firmware update. Yes, we can online update via service. We can also local update. We have manual how to do it. Do you need to connect current transformers? Yes, you have to. If you no connect current transformers, then you have incorrect data in app and cloud. Length of CT wires. You have up to 50 meters. Cable 24 AWG. Can the inverter work without batteries? Yes, inverter can work without batteries. Can the inverter work without the grid? Yes, inverter can work without the grid. Is the backup output three-phase? Yes, backup output is three-phase, but you can connect only one or two-phase. It depends for you. What is the output power of the backup? Output power on the backup is the same like power inverter. The most common mistakes made by installers. Wrong direction of phase rotation. The inverter is not working with the grid. Wrong order of current transformers. Colors. Incorrect data in the application. No current transformers connected. Incorrect data in the application. Connecting the whole house to the backup. It's easy to overload. Things to remember. Before commissioning, the current transformers must be correctly connected. Do not disconnect the current transformers during operation. Check the phase rotation direction. Update the firmware of the inverter and Wi-Fi module. The pluses of our hybrids. 2 backup outputs, including one with saving mode. 3-phase backup outputs, but also only 1 or 2 phases can be connected. No need to use additional and costly components such as reserve switching system. No need for additional two-way smart meters. Possibility to work without batteries, like a regular inverters with the possibility of extension. There are 4 operating modes to choose in Solplanet app. I will describe each of them in a moment. I would like to add that we are developing this product all the time, and there may be more possibilities soon. Self-consumption mode. Solar energy provides power to the loads as firstly priority. If solar energy is sufficient to power all connected loads, solar energy excess power will provide to charge battery, and then redundant power will feed to grid. Solar energy provides power to the loads as first priority. If solar energy and battery are not sufficient to power all connected loads, energy with grid will supply power to the loads with solar energy at the same time. If we don't have battery, then solar energy provides power to the loads as first priority. If solar energy is sufficient, the excess power will feed to grid. The inverter works like as basic on-grid inverter. If we don't have battery, the solar energy provides power the loads as first priority. If solar energy is not sufficient to power all connected loads, grid energy will supply power to the loads at the same time. The inverter works like a basic on-grid inverter. Work modes, custom mode. If we set charge time. On charge time, solar energy will charge battery as first priority. The excess energy will supply power to the loads. If solar energy is sufficient to supply loads and charge battery, and if there is still some extra energy, then the excess power will feed the power to the grid. On charge time, solar energy will charge battery as first priority. Then the excess solar energy will supply power to loads. If solar energy is not sufficient to charge battery and supply loads, grid will supply all the connected loads with solar energy together. If we set discharge battery. On discharge time, solar energy and battery provides power to the loads as first priority. If solar energy and battery is sufficient to supply loads, and if there is still some extra energy, then the excess power from solar energy and battery will deliver to power to the grid at the same time. If we now set charge or discharge battery. In the period of the charge or discharge battery, the solar power supply loads of first priority excess energy to the grid. When grid battery is available, PV is disconnected or is night. On charge time, grid will charge battery and supply power to the connected loads at the same time. On discharge time, if load power is less than battery power, battery will supply power to loads as first priority. The excess power will be fed to grid. On discharge time, if load power is more than battery power, battery and grid will supply power to the loads at the same time. Work modes, reserve power mode. When PV, grid, battery is available. Solar energy will charge battery as first priority. If solar energy is excess, the excess power will supply load. If there is still some extra energy, then the excess power will feed the power to grid. Solar energy will charge battery as first priority. If solar energy is excess, the excess power will supply load. If solar energy is not sufficient to charge battery and supply loads, grid will supply power to loads. When grid battery is available, PV is disconnected or is night. Grid will supply power to loads and charge battery at the same time. Off-grid mode. When PV battery is available, grid is disconnected. Solar energy provides power to the loads as first priority. If solar energy is sufficient to power all connected loads, solar energy will provide to charge battery. Solar energy provides power to the loads as first priority. If solar energy is not sufficient to power all connected loads, battery energy and solar energy will supply power to the loads at the same time. Zero export function. When we set zero export function, the inverter now will feed to grid. The pluses of our hybrids. 2 backup outputs, including one with saving mode. 3-phase backup outputs, but also only one or two phases can be connected. No need to use additional and costly components such as reserve switching system. No need for additional two-way smart meters. Possibility to work without batteries, like a regular inverters with the possibility of extension. Thank you for your time, and I hope that this presentation will be useful for you. Thank you very much.